Okay, binomial expansion. So this is kind of a cool thing. Obviously with computer-based systems and things like that, right? You just punch something into your computer, hit enter, and it gives you all the information you want. But before that, there was this process of dealing with binomials. And binomial, can you give me an example of a binomial?
I was just going to ask what a binomial is.
Oh, wow, what a great question, Professor. What's a binomial? Bi means how many? Two.
Terms.
Yeah. So it would be
X's.
X's.
X squared and X. No, an X and a non-X.
Sure. Yeah, if it was like x plus x, that'd be 2x, which wouldn't be a binomial. But if it was like x plus 5 or x squared plus 7 or something like that, yeah, so that'd be a binomial. So if we look at a binomial, let's look at this. If we have a plus b, that's a binomial, right? And that's just a plus b. So if we took another binomial though and said a plus b quantity squared, if we were to FOIL that out, okay, what does that a plus b quantity squared FOIL out to be?
A squared plus AB, 2AB plus 2AB plus B squared.
Yep, so a squared plus 2ab plus b squared. Very good. And then if I have a plus b quantity cubed, okay, we'll do just one more of these. What does that come out to be?
A cubed.
A cubed, good.
Plus
Something plus something.
2A squared B.
It is a squared b, but it's not 2.
Just A squared B. 3A squared B.
3, and then,
Plus 3AB squared.
nice. Okay. Wow. Nice work. Now you want to try to the fourth?
A to the 4
Mm-hmm.
plus 4 A to the third B plus 4 2 3 0 1 5 8 6 plus 6 A squared B squared plus 4 B cubed A B cubed plus B 4.
Nice. Okay. You want to try one more?
I don't know.
You got that one.
After guessing everything over, that was wrong. So we'll probably have A through 5. 5 A to the 4 B plus 10 A to the 3 B squared plus 10 A squared B cubed plus 5 AB to the 4th plus B to the 5. Wow.
Now, if we were going to take this, I should have started here. That's a plus b. Let me erase this. What if we had had a plus b to the 0? Well, what's a plus b to the 0? 1. Okay. Vince may have caught on to the pattern.
I think I did.
You did?
I don't know why it's 6 instead of 8 on through 4. Because on this next one, it's just double the 5 to the 10. But on the top one, it's,
Oh, you doubled it, and that wasn't the pattern then.
well, I tried to double it up on that top one.
Yeah.
So I,
Yeah. So what this is this gives us, if you look at it, we're forming a
triangle.
triangle, and it's actually called Pascal's triangle. And Pascal's triangle takes all the coefficients and creates a coefficient for binomial expansion. So we would start with 1, and then what's the next thing? 1, 1, and then 1, 2, 1, right? And then 1, 3, 3, 1. Move out of the way. 1,
4, 6, 4, 1.
And then 1,
5, 10, 10, 1, 5.
okay, and then you want to venture what the next one would be.
1, 6, 8.
Find the next one, you gotta look at the previous line.
15.
Is it 20?
15. 6,
Okay, let's try one more.
1, 7.
21.
Yep.
35. 35. 21. 71.
Okay, we've caught on. So you take your 2 here, add together, gives you there. Take 2 here, add together, gives you there. Keep going like that, add it together.
That's not what I was doing.
Oh.
I was.
And you
here's
can
what I
go
was doing.
1 and 6 is 7,
Mm-hmm.
that's fine. But you can also recognize it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right?
No, I was looking at from 6 to 10 is 4 right there in that diagonal line. 10 to 15 is 5. 15 to 21 is 6.
And that also works, yeah, because you're going up by 3, up by 4, up by 5, up by 6, up by, yep. So that's another way to look at it. So what this does is this tells us a plus b to the 0 to the 1, 2, 3, 4, 5, 6, 7. So a plus b to the 8th, okay. So when you have a problem and you're like, okay, I want to figure out what is, and we can do this one, a plus b to the 8th power, rather than having to FOIL out a plus b to the 8th, you simply go to Pascal's triangle and say, okay, a to the 8th, we know that is the start. So it would be 1, and then 8, and then, so the next one would be plus 8,
Plus
right?
20.
a to the, and you go down. You descend in A's, ascend in B's. So this is like b to the 0 here, b to the 1. So 8, 7, b. Now you'll always notice, well, let's do one more, and then
28.
28, right? So that's 28, 28, a to the 6, b squared. You're always going to notice 7 and 1 gives you 8, 6 and 2 gives you 8. So those are always going to add up to be whatever the exponent is there. Plus
56.
56, a to the 5th, b to the 3rd, plus
56. 70.
70, a to the
4. B to the 4.
plus
56. A to the 3. B to the 5.
plus
28. A to the 2. B to the 6. Plus 8. A. B to the 7. Plus B to the 8.
oops, b to the 8th. Yeah. Okay, so that's the binomial expansion with Pascal's. It gets not necessarily really complicated, but it gets a little bit more challenging when we tack on something like this. Let's say we have the square root of x plus 3 to the 4th power. Now, and actually, let's do this. Let's just go minus 3 so we can practice the minus portion in there too. So with this, you could actually just FOIL this out to the fourth, right? Or we can get a Pascal's triangle, right? We look here. So, but instead of A's and B's, what are we going to use?
X.
Root X's and negative 3's. Important to do the negative portion in there. So when we look at the fourth, the first one is, and we can simplify it later, root X to the fourth. Now we can say plus is fine. We would say plus, and because we're gonna simplify it later. Coefficient of 4 root X
to the 3 through negative 3.
to the 1, but we don't usually write to the 1. Plus
6 root X to the squared times negative 3 squared. Plus 4 root X times negative 3 cubed. Plus 4 negative, or no, just negative 3 to 4.
Yeah. And then you simplify that. What's root X to the fourth?
2x.
X.
Well, no. X squared.
X squared. Plus, or is it plus?
Minus
Minus
X root X.
What about the 4 and the negative 3? Minus
12.
12x root X. Okay.
Plus 12. 18. What?
It's
56. 54.
There we go. 54
X.
X. Where do we get 54 from? Help our viewers online that are struggling.
Well, we square negative 3, which is 9, times 6 is 54.
Very good. Yeah, not 12, not 18, not 56. 54.
Mrs. Hawkins told me after I took her math class in 8th grade that I needed to work on my time tables.
She was right. And did you?
No.
Okay, now what?
Minus
Minus
108.
because this is 27 times 4 root X plus
81.
So you're not going to see Pascals like in this, but we see Pascals in 1, 4, 6, 4, 1. Questions on that?
Makes sense to me. If I had seen a picture of the board at the beginning of the year, I probably wouldn't have even taken this math class.
Have you seen a picture of the board?
Yeah, because those numbers are so big and intimidating.
And now look how far you've come. Where is the got it? Where is the got it? Okay, let's get started on our H dubs.